Section 10.5 is about conic sections. It's parabolas, ellipses, hyperbolas, and their standard equations. It looks very much like it did in pre-calculus. There's not much difference here. I don't know that there's any. I think 10.6 is where you start to see the difference. So let's do a brief overview. But these are called conic sections or conics because they result from intersecting a cone with a plane. So you can see we have an ellipse, a parabola, and a hyperbola. And a parabola is defined as the set of points on a plane that are equidistant from a fixed point called the focus and a fixed line called the directrix. So for our parabola, we know that x squared equals 4py is our equation. When we have a focus, the focus is 0p, and the directrix is y equals negative p. And so if we interchange the x and the y, then we have y squared equals 4px. And we find the focus to be p0, and the directrix is x equals negative p. So that's your parabola. And you've done this in pre-calculus, so I think it makes pretty good sense. We'll look at one in just a minute. Make a note of the formulas, they're important. So then we look at an ellipse. So the ellipse is the set of points in a plane, the sum of whose distances from two fixed points F1 and F2 is a constant. So these two fixed points are called the foci, and singular is focus. So one of Kepler's laws is that the orbits of the planets in the solar system are ellipses with the sun at one focus. And the formulas we have here are for an ellipse. We have x squared over a squared plus y squared over b squared equals 1, where a is greater than or equal to b, which is greater than 0. And the foci are plus and minus c, comma 0. And the vertices are plus and minus a, comma 0. So c comes from the fact that c squared equals a squared minus b squared by definition. So when you have this, on this instance, your major axis is your x-axis because your foci are on your x-axis. Your longer length is your x-axis. Your vertices are your x-axis. The alternative is x squared over b squared plus y squared over a squared. And in this problem, we still have a is greater than or equal to b is greater than 1. And your foci now are on the y-axis. So you have 0 plus or minus c, and your vertices is on the y-axis. So you have 0 plus and minus a, and c is defined to be the same. C squared equals a squared minus b squared. And you can see that your larger denominator is under the y, so that tells you your ellipse is on the y-axis. Let's do an example of that real quick. It says 9x squared plus 16y squared equals 144. So if we divide everything by 144, because it's not a parabola, hyperbolas and ellipses both need to be equal to 1 before you work with them. So when we divide by 144, we end up with x squared over 16 plus y squared over 9 equals 1. Now to use your formulas, that tells you that a equals 4 and b equals 3. So in my head, I think that the square root of 16 is plus and minus 4, and it's underneath the x. So we go out to positive 4 and negative 4 on the x-axis. And the square root of 9 is 3, so we go up to 3 and down to negative 3 on the y-axis. And that gives us our ellipse. So you can see how the ellipse happens. Mine's a little out of scale, but it's okay. And then you say c squared equals a squared minus b squared, and a is always your larger number. You can't have a negative c. It needs to be a real number. So 4 squared is 16, minus 3 squared is 9. So c is plus and minus the square root of 7. So that tells you that your foci, since you're on the x-axis, Those are x values. So your foci is plus or minus the square root of 7, comma 0. Your foci are on your major axis. So you don't have to really memorize all of that. You have to be able to understand that your foci are on your major axis. So a similar one says we have a foci. Let's hit that. The foci, it's an ellipse, and the foci are 0, plus and minus 2, and the vertices are 0, plus and minus 3. So that tells me right away that A equals 3 and C equals 2. So we can find B because C squared equals A squared minus B squared. So 4 equals 9 minus B squared. Negative 5 equals negative B squared. So the square root of 5 equals B. So then when you fill this in, you have x squared over something plus y squared over something equals 1. Now your A squared, because your values are both in the y side, then that means y is your larger number. So A squared is 9, goes under y, and B squared is 5, goes under x. So that's your equation for your ellipse. You could always multiply it out for standard form. 9x squared plus 5y squared equals 45. So these are your two answers for your equation of your ellipse. So it's not very difficult if you get your formulas and get them set. So lastly, we have a hyperbola. There's a couple interesting things about hyperbola. The hyperbola looks like two opposite parabolas, and there's kind of a box that happens. Let's see, there's kind of a box that happens here, and your asymptotes go through the box, and that's how your hyperbola is drawn. Now the hyperbola looks like an ellipse. It says x squared over a squared or b squared minus y squared over b squared equals 1. So the difference is that minus. So instead of it curving in to make an ellipse, it curves out to make the hyperbola, and the minus is what makes that happen. So let's look at these pictures. So we have two things happening here. Figure 12 is where the y is minus. So notice your hyperbola sits on the x-axis. And in figure 13, when the x is minus, your hyperbola sits on the y-axis. So we have two equations. Let's take the top one. It says x squared over a squared minus y squared over b squared equals 1. And then the foci are, again, it's plus and minus c, comma 0. And the vertices are plus and minus a, comma 0. And the asymptotes, I didn't leave enough space. Let's move this over. The vertices again are plus and minus a, comma 0. And the asymptotes are y equals plus and minus b over a times x. So it's not very hard to draw. I'll show you that in a minute, just in case you don't remember your pre-calculus. And then when you look at that, everything's on the x-axis. Your parabolas are on the x-axis. Your foci are on the x-axis. Your vertices are on the x-axis. In the second one, you have y squared over a squared minus x squared over b squared equals 1. So your foci are 0 plus and minus c. Your vertices are 0 plus and minus a. And your asymptotes are y equals plus and minus a over b x. So let's look at one of these because it sounds more difficult than it is. So we have, let's start with the standard form. Let's do the same equation. It's a very common one. 9x squared minus 16y squared equals 144. Now notice they have a minus in it, so it's automatically a hyperbola. Different coefficients means it's not a circle, but the minus tells you it's definitely a hyperbola. So divide by 144 and you get x squared over 16 minus y squared over 9 equals 1. Now since my larger number is on the 16, that tells me that I'm in my x-axis. So again, a equals 4, b equals 3. We can find c one more time. Oh, your equation for C is different. So let's go back and make that note. Note down here your C, because it's a minus, C squared equals A squared plus B squared. And we'll look at Y. So let's leave C for a minute. Here we have positive 4 for X and negative 4 for X. Then we have positive 3 for Y and negative 3 for Y. And the best way to draw this hyperbola is to make a box like this. Now you draw dotted lines going through these. These are your asymptotes. And from there you can draw your hyperbola. Now since the larger number is under X, I know that this is on my X-axis. And that's true over here as well. So that's the hyperbola. And then you need the foci. And the foci, C equals A squared plus B squared. And we know that that means C equals 5. So your foci are here at positive 5 and over here at negative 5. So hopefully that'll help you see it. The last thing in this section is transformations. So if we have, let's say, x minus 3 quantity squared over 4 plus y plus 2 quantity squared over 3 equal to 1. Now it's a plus, so it's an ellipse. If it was a minus, it would be a hyperbola. So when you look at this, your center is at 3, negative 2. So here's your center. And then you're going out 2 spaces on your x-axis. So we're going out to here and to here. And then you're going out, you're going up and down the square root of 3, which is approximately 1.7. 1.73. So it's a little less than 2, so it's going to come up like this and down like this. So it's very close to a circle in this one. So you can see that happening. I think we'll do one more. This problem says find the equation of the ellipse, and the foci are negative 2, negative 2, and 4, negative 2 for the foci. And the vertices are 1, negative 2, and 5, negative 2. So if you look at the fact that the y values match, the distance between 1 and 5 is 4. So that means that a equals 2, because the square root of 4 is 2. And then the distance between the foci is 2, because from 2 to 4 is 2, so that tells me that c equals 1. It's half. Half of 4 is 2, and half of 2 is 1. And then we can find b, because we know this is an ellipse. So c squared is a squared minus b squared. So we get 1 equals 4 minus b squared. So negative 3 equals negative b squared. So b is the square root of 3. There are several ways to come up with the next, but let's look at the foci and the vertices. The center of both is 3, negative 2. So that is actually the center of our ellipse. So that means we can say x minus 3 quantity squared plus y plus 2 quantity squared over something equals 1. And a is 2, so we're going to put a 4 here. And b is the square root of 3, so this is 3. So that's how you come up with your equation for your ellipse. Thank you. I think you've got all you need to do your work. Have a great day.